and welcome to ISRO. So today in this video, we'll be talking about the very first mission to the sun, Aditya L1. Indian Space Research Organization has sent this mission to study the sun. So let's talk in detail about this. Before that, I would like to tell you, you can enroll with ISRO for the prelims cum mains program, where you'll be getting live classes, one-to-one mentorship session, unlimited recorded access, and personalized strategy plan to make your preparation easy. So let's begin with our topic. India has launched Aditya L1 mission to study sun in the starting week of September. It is the first space-based observatory. Now, what is space-based observatory? When we talk about Chandrayaan, it landed on the moon to do the further studies and research. But here, it will not land onto the sun because that's not possible because of the extremely high temperature over there. So therefore, this mission will stay in space at a particular point, and staying in space, it will do its observation and collect data for the research purpose. That is what is known as space-based observatory. It will be launched using PSLV C-57. PSLV, as you might have seen in the previous video, Polar Satellite Launch Vehicle with solid, liquid stages. So here, PSLV C-57 is being used. Now, let's study in detail about the mission. The mission aims to provide valuable insights into solar corona, photosphere, chromosphere, and solar wind. When we talk about a sun, this is a sun. The outer layer is known as photosphere. Uske andar jab hum jaate hain, then is chromosphere. So Aditya L1 mission will be studying both these layers, photosphere also and chromosphere also. Along with that, all the mass that is ejected, all the magnetic field that is repelled out of the sun, the coronal mass ejection will also be studied by Aditya L1 mission. These will be studied under the mission. Now, the primary objective will be studying how the sun behaves, how the radiations are given out, how the heat particles flow, and how the magnetic field impact the earth. Now when we see our sun has some sunspots. Here you can see the word sunspot is mentioned. What is sunspot? Sunspot is nothing but they are the darker areas on the sun. Darker areas इसलिए बोला जाता है because they appear to be dark when seen through a image captured by the various telescopes. Now these are darker because they are cooler spots on the sun. Why they are cooler? They are cooler because वहाँ पे magnetic field इतनी massive रहती है that it doesn't let the ejection out. So therefore it appears to be darker, and then it is here. You can see umbra. This is the umbra region, the darker region, and this is penumbra, the lighter region. This is penumbra, the lighter region. Here these sunspots, these are sunspots which are the darker region. Darker के साथ साथ ये क्या कहते हैं? Cooler. Okay. So this will be also studied by the Aditya L1 mission. Both these because they have an impact on Earth. क्यों? कैसे impact होता है? They even impact the monsoon cycle. El Nino पे भी impact होता है. They impact the weather pattern on the Earth. Therefore, this study and detailed analysis is needed. It will study solar flares and coronal mass ejection. As I told about coronal mass ejection, the ejection magnetic particles which are thrown out of the sun. Okay, and then Aditya L1 mission will carry 7 payloads. It will be carrying 7 payloads. Here you can see these are the 7 payloads. VELC, Visible Emission Line Coronagraph, Sun Ultraviolet Imaging Telescope, Helio 106, High Energy L1 Orbiting X-ray Spectrometer, SOLEX Solar Low Energy X-ray Spectrometer, and Plasma Analyzer Package for Aditya, SPEX, Aditya Solar Particle Experiment, and Magnetometer. These 3 mentioned below. Plasma Analyzer, Aditya Solar Wind Particle Experiment, and Magnetometer. These 3 payloads will be used for in-situ study. In-situ study means वहीं के वहीं study करना. The particles which are situated over there on the point where Aditya L1 mission will be there. Aditya L1 mission is situated on L1 point. We'll be talking about this. So L1 point पे जितने भी particles हैं उनकी in-situ study के लिए ये 3 payloads हैं, and the other 4 payloads will be used for studying the sun. One will be studying about the emissions which have been thrown out, coronal mass ejection. Other will be ultraviolet imaging telescope for the images, and the Helios high energy spectrometer for studying the various wavelengths, and the solar low energy X-ray spectrometer. Okay, so these are the 7 payloads. 4 for the study of sun, and 3 for the study of in situ L1 point particles. Okay, I hope this is clear. So now let's see where Aditya L1 mission will be situated. Now, as the name suggests, Aditya L1, this L1 is nothing but the position which is known as Lagrange point. This Lagrange is named after the Italian scientist who discovered these points. There are 5 points, 5 Lagrange points, L1, L2, L3, L4 and L5. So, Aditya L1 mission is on the point L1. See this. Now, what is Lagrange point? Lagrange point is a point in the space where two heavy celestial bodies gravitational force cancel out each other such that अगर अपन third body को place करते हैं, so it is equal to the centripetal force of both the body and the third body moves with the other body. वहाँ पे gravitational pull cancel out हो जाता है and it stays over there and moves with the other body. And the biggest benefit of it is lesser fuel consumption. आप कोई भी स्पेसक्राफ्ट भेजोगे, उसके मूवमेंट के लिए यू रिक्वायर मैसिव फ्यूल, उसकी लाइफ कम हो जाएगी बिकॉज वी कैन नॉट प्रोवाइड दैट मच ऑफ फ्यूल. दैट्स वाई आदित्य L1 मिशन इज प्लेस्ड एट L1 पॉइंट. यहाँ पे जो सन की ग्रेविटेशनल पुल है एंड जो अर्थ की ग्रेविटेशनल पुल है, इट विल कैंसल आउट ईच अदर such that L1 will stay over there without much fuel consumption and it will move simultaneously with the movement of earth. जैसे जैसे अर्थ का मूवमेंट होगा around the sun, it will move around this. Okay, so when we talk about the Lagrange points, let's see other Lagrange point. There are 5 Lagrange point. L1, where mission Aditya is placed. This is not the only mission placed on the L1 point. There is one more mission placed on L1 point. That is SOHO, Solar and Heliosphere Observatory Satellite. This is a mission of European Space Agency. European Space Agency का mission already L1 point पे है. And then is the second point, L2 point. L2 point is positioned behind the earth. Now here you can see L1 earth के आगे है. Okay, L1 is in front of the earth such that the shadow is not casted. This is L1, earth के आगे. And similarly behind the earth is L2 point. Okay, beyond the sun, beyond the earth, this is a L2 point. यहाँ पे at present, you know what is situated? James Webb Telescope. The James Webb Telescope is in the L2 point. James Webb Telescope is in the L2 point such that this point is used for the study of outer space without any hindrance. Okay, and here it is used to study sun without any hindrance of eclipse. Okay, so these were the both L1 and L2 point. Let's come to the L3 point. Now this is behind the sun. Okay, L1 अर्थ के आगे, L2 अर्थ के पीछे, L3 is behind the sun, sun की पीछे side to study the far side of the sun. So we can see L3 is situated on the other side behind the sun to study this far side of the sun. Okay, so this was L3, and then L4 and L5 are the stable position. They are stable position forming an equilateral triangle. As you can see, L4, this is forming a triangle. Here you can see L4 and L5. This is L4 and it is forming a triangle with the earth and the sun, equilateral triangle. This is a stable point. Okay, L4 is a stable point. Similar is the case with L5. L5 is also forming an equilateral triangle. This is also a stable position. Now when we talk about L1, L2 and L3, they all three are unstable. Okay, these are unstable. Unstable in the sense थोड़ा सा भी disturbance होगा. Our satellites or our missions will be disrupted. They had to be constantly studied. Okay, so because these are unstable points. So these were the 5 Lagrange points, and our Aditya mission, as I said, is on L1 point. Okay, so now let's see mission Aditya. Here is the earth. It will circle around the earth. इसका रेडियस बढ़ेगा धीमे धीमे. when it will escape the velocity of the earth, escape velocity को counter करेगा. It will reach out to the outer atmosphere and then enter the point. This point, Lagrange point, is 1.5 million kilometer far away from the earth to study the sun. Quite a long distance. So this was the position of Aditya L1 mission. So now why do we need to study the sun? Because it is one of the most important part of a solar system, and to study how our solar system evolved, how this whole process took place, how celestial bodies were formed, we need to study the sun. weather prediction. As I said, these coronal mass ejection will come out on solar flares, as I said, have an impact on our weather conditions. That's why they need to study. They also have impact on our satellites and other missions. They can disrupt our satellites. So we need to study about them so that we can take precautions and cope up with the unforeseen situations. So this is needed for predictions and understanding sun's magnetic field, the sunspots, the darker areas and the lighter areas. The magnetic field which is being ejected out from the sun needs to be studied, and the improving satellite operations so that they do not get disrupted. So this was all about Aditya L1 mission. If we succeed in this mission, this would be the first ever sun mission from ISRO, and we'll definitely move a great ahead in space race with achieving new heights. So let's hope for the best of this mission. I hope you like the video. Do like and comment, and for more such videos, subscribe to our channel IS Origin. Thank you.